Hello friends, welcome back. Hearty welcome to you. Let us look at this linear programming problem. A man has 1500 rupees for purchasing wheat and rice. A bag of rice and a bag of wheat cost 180 and 120 respectively. He has a storage capacity of only 10 bags. He earns a profit of 11 and 9 respectively per bag of rice and wheat. Formulate the problem as an LPP to find the number of bags of each type he should buy for getting maximum profit and solve it graphically. So first we have to formulate, after that we have to solve it graphically. So let's understand this problem. A man has 1500 rupees for purchasing wheat and rice. A bag of rice costs 180 rupees and a bag of wheat costs 120 rupees. Now the total purchasing capacity he has is only 1500, so we have a constraint there with respect to the cost. We also have a storage constraint here. We can have only max 10 bags. So let us say, suppose wheat is X bags he has taken and rice is Y bags. Then we have X plus Y should be less than or equal to 10. And what is that we have to maximize? What is our objective function to be maximized? The function to be maximized is profit. So profit comes from 11 rupees for each wheat bag and 9 rupees for each rice bag. So the total profit will be 11 into X plus 9 into Y. That means our Z, which needs to be optimized, is 11X plus 9Y. So let's take this information to understand it easily. We'll just put a table. Since we are discussing about rice and wheat, so I'll write down that. We'll say rice here and we'll say wheat here, and we want to know any constraint for that particular row. Now let us say number of bags. What we need to find out, X and Y values. Say rice number of bags is X and wheat is Y. When we go through that, we understand storage capacity of only 10 bags. So there is a storage constraint. Now rice X bags you are storing, wheat Y bags. Constraint, what is the constraint? X plus Y should be less than or equal to 10, because he can only store 10 bags. Then what is the other constraint we have? The other constraint is with respect to the purchase. So total amount purchasing constraint we have. So let's write down now what is the price of each bag. We know that rice is 180 rupees and this is in rupees, and wheat is 120 rupees. Now then what will be the total cost or the total amount needed to purchase X rice bags and Y wheat bags? That is amount, total amount is 180, each bag is 180, multiply with X. Then similarly 120 into Y. What is our constraint? 180X plus 120Y should be less than or equal to 1500, because the max amount he can spend is 1500 rupees. Now also we know that number of bags cannot be less than or equal to 0. Can be 0, cannot be negative. So X greater than or equal to Y greater than or equal to 0. So let's write down all the constraints we have. X greater than or equal to 0, Y greater than or equal to 0, X plus Y less than or equal to 10. Then we have 180X plus 120Y less than or equal to 1500. Now we can simplify this. We can divide with 60. We'll have 3x plus 2y less than or equal to 25. Now what is our function to be optimized? That is Z. Z will be nothing but equal to profit of 11 for each bag. That means from rice it will be 11x. Then from wheat it will be 9 into y, 9y. So we have to optimize, or we have to maximize our profit. So to get the maximum profit, what should be our x and y values? So once we got all the constraints whatever we need and the function we know, we will now graphically we have to solve this by using corner method. We have to graph these straight lines, then we have to get our corners so that we can find out the maximum profit. Now let's draw the graph. First we will take x plus y equal to 10. So when x equal to 0, y is 10, and y equal to 0, x is 10. So the point will be 10, 0, and the other point will be 0, 10. So this is our line x plus y equal to 10. So we got that. Then the next one, what we have to do is 3x plus 2y less than or equal to 25. Put x equal to 0, then we will get y equal to 25 by 2. Put y equal to 0, we will get x equal to 25 by 3. So 25 by 3, let us say it comes here, 25 by 3, 0, and the point we have on the y-axis is 0, 25 by 2. So let us say this is 0, 25 by 2. This you will be doing in exam in graph. Here I am just roughly doing this. Now let's join this line also, 0, 25 divided by 2. Okay, now we have both the straight lines. Now we have to understand whether the feasible region is bounded or unbounded. So let us take x plus y less than or equal to 10. Now how to find out where the region will be? Put substitute 0, 0, 0 plus 0, 0 less than or equal to 10. That means the solution for this linear inequation is towards where the origin is. That means x plus y less than or equal to 10 will be going in this direction. That's what we have. Now let us look at the next one, 3x plus 2y less than or equal to 25. Again substitute x 0, y 0, we get 0 less than or equal to 25. That means again we need to go to the plane where 0 is there. That means we have to consider this side, we have to take it. So let's go ahead and plot that or draw that. We will have like this. Now from this you can see the region which is bounded by both of them. That is nothing but this is the region which is bounded by both the curves. So this is the polygon we have. Now we have to find out the corner points of this. We know already this is 0, 10. We know this is 0, 0. We know 25 by 3, 0. Now we don't know this point, so we'll find it out. For that what we will do, we'll solve this two linear equations. One x plus y equal to 10. Another one is 3x plus 2y equal to 25. Multiply the first one, we will have 2x plus 2y equal to 20. Now subtract them, you get x equal to 5. Y equal to 5. That means we know this point is 5, 5. Now once we know the corners and we know this is a simpler problem because it's a bounded region, so pretty much easy. Let's go to the last step, that is where we'll put down our 11x plus 9y for different values of the corners of the polygon and try to understand what will be the maximum value or which values of x and y will give us maximum profit. Now we'll find out the maximum value of the function, objective function. So we have written z equal to 11x plus 9y. We know the corners coordinates, we have written it. Now we will substitute. Suppose let us say x equal to 0 and y equal to 10, the value will be 11 into 0 plus 9 into 10, which is equal to 90. Let's go to the next one. That will be 0, 0, so it will be 0. The next one will be 25 by 3 into 11 plus 0, which is 275 divided by 3, approximately equal to 92. Let's go to the next one. We have 11 into 5 plus 9 into 5, which is 55 plus 45 equal to 100. So the maximum value we get out of all of them is 100 is the maximum value. So our x and y values should be x equal to 5 comma y equal to 5 is the values of the number of bags that he needs to purchase, so that subject to all the constraints he can maximize his profit. So this is a very simple problem in LPP, a problem where you have bounding region is bounded and it's easy to solve. We'll do more problems. This is the first problem in this particular series. Thanks for your time and support. Bye for now.